June 1944. While Cambridge-trained explosives engineers were designing complex electromagnetic mine detectors trying to solve the crisis that was costing the Allied forces entire battalions in the Normandy hedgerows, a 22-year-old private from rural Alabama with barely an 8th grade education grabbed a rusty bucket, some scrap wire, and a handful of nails, and accidentally detected 40 German mines in 3 hours without setting one off. How did a detection method so simple that it cost less than $2 completely escape every demolitions expert, every Royal Engineer, and every ordnance specialist in the Allied command? The rain hadn't stopped for 2 days. It had turned the Norman countryside into a treacherous mud trap that hid death in every footstep. Private Tommy Reeves knelt beside a hedgerow outside Saint-Lô, watching another engineer squad inch forward with their standard mine detectors, sweeping slowly, methodically. Each sweep took minutes. Each cleared meter represented another hour the advance couldn't move forward. Another squad pinned down, another attack delayed, another German position that would claim more lives because nobody could move through the minefields fast enough. This is the true story of how a 22-year-old Alabama farm boy stumbled onto a mine detection technique that would clear the Normandy hedgerows and change combat engineering forever. But on that rain-soaked morning outside Saint-Lô, nobody was listening to Tommy Reeves. Nobody thought a sharecropper's son from Tuscaloosa County could solve a problem that had stumped the best minds in Allied ordnance disposal. The numbers told a grim story. The Allied advance was losing 12% of its forward infantry to mines before a single soldier engaged the enemy in direct combat. 12%. That meant for every 100 men who pushed into the hedgerows, 12 were dead or maimed by buried explosives before they ever saw a German soldier. 12 men per 100 simply vanished in explosions, screaming, or silent death depending on where they stepped. 1 in every 5 engineer squads failed to clear their assigned sectors at all. The mine detectors simply couldn't work fast enough in the Norman mud. Their precious advance timetables shattered. Their carefully planned attacks stalled while German forces dug in deeper and positioned artillery. The Allied forces were bleeding men, and the bleeding was getting worse. Without faster mine clearance, the entire breakout from Normandy teetered on the edge of collapse. Infantry divisions sat paralyzed for lack of cleared routes. Tank columns couldn't advance into position. Artillery units went without forward observers because the approach path through the hedgerows were too dangerous to traverse. Because the standard mine detectors took too long, missed too many mines, and left soldiers dying in fields that were supposedly cleared. Field Marshal Erwin Rommel understood this perfectly. He watched Allied forces crawl through Normandy like wounded animals, their advance strangled by minefields, their momentum bleeding away with every explosion. Every delayed advance gave him another day, another defensive position, another chance to throw the invasion back into the sea. Tommy Reeves was nobody special. He'd grown up on a sharecropper's plot outside Tuscaloosa during the worst years of the Depression. His father had taught him to find water underground using a forked willow branch and patience because drilling wells cost money they didn't have. His grandfather had taught him to feel the ground, to read the earth like some people read books. School ended when Tommy turned 14. His family needed him full-time in the fields. There were crops to tend, land to work, and no money to keep a boy in school when his hands were needed for cotton picking. But Tommy understood the earth, the way some people understood music or mathematics. He could walk across a field and know where the ground was firm, where it was soft, where water ran underneath. He could feel changes in the soil through his boots. His grandfather said Tommy had ground sense, the kind of knowing that can't be taught, only inherited or ignored. When war came, Tommy enlisted on his 21st birthday. The Army tested him, found that he could barely read a field manual, and sent him to France as a combat engineer. Not a demolitions expert, not an officer, just a private who dug foxholes and followed orders. That's what he was doing outside Saint-Lô in June 1944. Digging, hauling equipment, watching engineer squads sweep for mines with their fancy electronic detectors, and wondering why the detectors missed so many mines that later killed men who thought the ground was safe. The Army cared, of course. They cared desperately. They had assigned their best ordnance engineers to solve the mine detection crisis. Men from Cambridge and MIT, experts in electromagnetic theory and electronics engineering, worked night and day on the problem. Their solution was to modify the standard SCR-625 mine detector. redesign the search coil geometry to improve sensitivity, install secondary oscillator circuits that would reduce interference from soil mineralization, optimize the audio feedback system to help operators distinguish between mine signatures and metallic debris, add waterproofing to handle the Norman rain. They tested dozens of configurations. The modifications helped a little. Detection rates improved maybe 8% on a good day under ideal conditions. But the changes were expensive, time-consuming, and required trained technicians to operate. Each modified detector cost over $400 to produce, required a specialist with 3 weeks of training, took 45 minutes to clear a 10-meter square section of ground. And 8% wasn't enough, not nearly enough. Other experts recommended chemical detection methods, special compounds that would react to explosive vapors in the soil, color-changing papers that would indicate the presence of TNT or composition B. The compounds worked in laboratory tests, but distributing millions of test strips to combat engineers in muddy French hedgerows was impossible. The supply chain couldn't handle it. The trucks that were supposed to carry the chemicals couldn't reach the front lines because they kept hitting mines on roads that were supposedly cleared. It was a problem that ate its own solution. High Command considered abandoning rapid advances entirely. Maybe the hedgerows couldn't be cleared fast enough. Maybe Allied forces would have to accept slow, methodical progress. Maybe Germany would stabilize the front simply because the Allies couldn't figure out how to move through minefields without losing men at an unsustainable rate.
Tommy watched all this happen. He watched engineers work on detector modifications. He watched officers argue about chemical testing papers. He watched squads move forward into cleared areas and step on mines that the detectors had missed. And Tommy noticed something that nobody else seemed to see. The mine detectors were finding the mines, most of them anyway, but they were also finding everything else. Spent shell casings, shrapnel fragments, barbed wire scraps, metal debris from destroyed equipment. Every piece of metal in the Norman soil set off the detectors, and operators had to investigate each signal individually. That's what made the process so slow. Not the detection itself, but sorting the real mines from the hundreds of false positives buried in ground that had been fought over for years. Tommy had grown up finding things underground. His grandfather used to douse for water using willow branches, but that was just for show, for the neighbors who expected the ritual. The real trick was understanding how the ground felt different, how it sounded different, how it responded to pressure. The standard mine detectors listened for metal. That was the problem. Everything in a combat zone was metal. Shell fragments, wire, nails, buttons, belt buckles, spent cartridges. The detectors couldn't tell the difference between a minefield and a rusty nail 3 inches down. Tommy mentioned this to the sergeant in his engineer platoon, a career soldier who'd been clearing obstacles since North Africa. The sergeant barely looked up from the mine detector he was calibrating. "Kid, we got Cambridge engineers on this problem. You think they haven't considered soil contamination? The problem is in the detector sensitivity settings. That's where the experts are focused. Get back to work." But Tommy couldn't let it go. He'd grown up on land where every square foot had to produce, where missing a rock that would break the plow blade meant losing a day's work. His grandfather had taught him to read the ground, to know what was underneath without digging, to feel the difference between stone and clay and sand just by how his boots settled. Tommy had spent his childhood learning that the earth talks if you know how to listen, not with electronics or chemicals or sophisticated instruments, just with patience and attention and the knowledge that different things feel different, sound different, respond different when you touch them the right way. The problem wasn't the detector's sensitivity, Tommy thought. The problem was that metal detectors can't tell you what kind of metal they're finding. A mine feels different than a nail. A mine sits different in the soil. A mine disturbs the ground around it in ways that shrapnel doesn't. But he was 22 years old with an 8th grade education. And who was going to listen to him? Tommy couldn't sleep. Every night he lay in his foxhole thinking about those mine detectors, sweeping slowly through the hedgerows, stopping for every piece of metal, wasting precious time investigating false positives while men waited to advance through ground that might still be deadly. He kept remembering something from his childhood, a memory that wouldn't leave him alone. His grandfather used to find sinkholes in fields before they collapsed, not by looking at them, but by tapping the ground with a long wooden pole.
Hollow ground sounded different than solid ground. A cavity underneath rang different than packed earth. His grandfather would walk through a field tapping, 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 listening to the sound the ground made when the pole struck it. Earth tells the truth, his grandfather would say. You just gotta ask it the right questions. What if the army was asking the wrong questions? What if those brilliant engineers were listening for the wrong signals entirely? Tommy started thinking about the mines themselves. German S mines, Teller mines, Shoe mines, all buried at different depths, all disturbing the soil in different ways. Metal detectors found the metal, but they didn't tell you anything about what was around the metal. A mine in the ground creates a void, a hollow space. The soil above it settles differently. It sounds different when you tap it. But you couldn't tap the ground with a pole looking for mines. That would set them off. You needed something that would test the ground without applying enough pressure to trigger the detonator. Something light. Something that would detect the void without pushing down on what was inside it. Tommy's idea was radical in its simplicity. Don't listen for the metal, listen to the ground itself. Don't use electronics to find disturbances in electromagnetic fields. Use sound to find disturbances in the soil structure. Make something that would tap the ground lightly, consistently, while moving forward. Something that would let an operator hear the difference between solid ground and hollow ground, between packed earth and the telltale void that a buried mine creates. He started experimenting in secret. After his regular shifts ended, Tommy would find quiet corners of the encampment, working in the twilight when everyone else was eating or sleeping. He pulled a battered bucket from the scrap pile, one that had been shot through twice and condemned for carrying water. Using a bayonet and a file from the toolkit, he punched holes around the bottom rim of the bucket. 8 holes, evenly spaced, each about the size of his little finger. Then he needed something to hang from the holes, something that would tap the ground when the bucket moved. Tommy found a spool of wire in a supply crate, the kind used for field telephone repairs. He cut 8 pieces, each about 18 inches long. At the end of each piece, he attached a nail. Not just any nails, but the longest ones he could find. 60 penny nails about 6 inches long. He fashioned small loops in the wire and attached each nail so it hung point down, swinging free. The nails threaded through the holes in the bucket bottom, 8 metal fingers hanging down, ready to tap the earth as the bucket moved. But Tommy wasn't finished. He needed a way to hear what the nails were telling him. He punched 2 more holes in the bucket's sides near the top and threaded a length of paracord through them as a carrying handle. Then he cut a small hole in the bucket's bottom center and attached a listening cone he had fashioned from a tin can with both ends removed.
The design was crude but purposeful. Drag the bucket forward slowly. The nails tap the ground. The sound travels up through the bucket. The cone focuses the sound. An operator walking beside the bucket can hear the tapping pattern through the cone, listening for the telltale hollow sound that means something is buried underneath. 3 weeks passed. Tommy worked every evening refining his bucket detector, testing different wire lengths, different nail weights, different dragging speeds. Nobody paid attention to what the farm kid was doing in the corner with his bucket and nails. He tested the nail spacing obsessively, making sure they covered the ground evenly. Too close together and they interfered with each other. Too far apart and they missed areas between the taps. He filled practice containers with soil and buried them at different depths, then dragged his bucket across them, listening to how the sound changed. Buried metal made a dull thunk. Solid ground made a consistent tap, tap, tap. But a hollow space underground, that made the nail bounce different, ring different, produce a distinct hollow tap that was unmistakable once you knew what to listen for. Tommy practiced for hours, dragging his bucket across test sections, learning to distinguish between rocks, roots, and the telltale acoustic signature of buried objects with air spaces around them. He marked known locations of buried debris, then tested his ability to detect them blind. His accuracy improved, 70%, then 80%, then 90%. The bucket detector could move continuously while testing, unlike the electronic detectors that had to stop and hover over each target. Drag speed could be adjusted for conditions. Wet ground sounded different than dry, but both gave clear hollow signatures over voids. And most importantly, the bucket ignored metallic debris. A nail in the soil didn't create a hollow space. A mine did. Now came the hard part. Tommy needed to convince someone to actually test his bucket detector on a real minefield. He approached his sergeant again, the same NCO who had dismissed him weeks earlier. This time, Tommy brought his bucket, dragged it across a test area where the sergeant had buried training mines the day before for a demonstration. The bucket's nails tapped across solid ground, then produced 3 distinct hollow rings over the training mines' locations. Tommy marked each spot with a stick. The sergeant dug them up, 3 for 3. The sergeant looked at the bucket, looked at Tommy, and shook his head. This isn't your job, Reeves. You're a combat engineer, not an ordnance specialist. You want to change how the whole army detects mines with a bucket and some nails? That's above your pay grade, way above. But there was one person who might listen. Lieutenant Marcus Webb commanded the engineer platoon attached to the 2nd Infantry Division. Tommy had helped dig Webb's command post bunker, and the young officer had always treated him with respect, never talked down to him the way some of the other officers did. Webb was also desperate. His engineers were taking casualties faster than he could replace them, and the advance through the hedgerows was measured in yards per day instead of miles per day. Desperate men take chances they wouldn't normally take. Tommy found Webb at the operations tent on June 18th. He brought his bucket detector and a hand-drawn diagram showing how it worked. Webb listened, which was more than anyone else had done. He watched Tommy demonstrate the dragging technique, heard the distinct hollow tap over a buried ration tin, saw how the device could move continuously instead of stopping for every signal. Then Webb asked Tommy a simple question. How much did this cost you to make? Tommy did the math in his head. Scrap bucket, salvaged wire, borrowed nails, paracord handle. Maybe $2, sir, maybe less if we're making them from materials we already have. Webb whistled low. The modified SCR 625 costs over $400 per unit. Tell you what, Reeves, I've got a hedgerow sector that needs clearing tomorrow. German positions 200 meters ahead. I'll let you take your bucket. We'll see if it finds anything the standard detectors missed. That was all Tommy needed. He stayed up all night preparing his bucket detector, checking every wire connection, every nail, every detail. He made a second backup bucket in case the first one failed. The patrol moved out at dawn on June 19, 1944. Lieutenant Webb accompanied them personally, along with 2 squads of infantry and a standard engineer team with electronic mine detectors. The standard procedure was to sweep with the detectors first, mark any signals, investigate each one individually, then follow with the advance. Webb ordered a different approach for this test. Send the standard detectors through first, marking the ground as clear, then send Tommy through with his bucket before the infantry advanced. The electronic detectors cleared a 50-meter section in 3 hours. 27 signals investigated, 27 false alarms. Shrapnel, wire, shell casings, no mines found. The sector was marked safe for infantry advance. Webb sent Tommy through with his bucket detector. Tommy dragged the bucket slowly forward, listening through the cone, hearing the nails tap against the Norman soil. Tap, tap, tap. Solid ground sounded consistent, rhythmic, dense. Then he heard it. A hollow tap. Different. Unmistakable. He marked the spot with a white cloth, moved forward. Another hollow tap, another marker. He worked systematically, covering the supposedly clear sector in 40 minutes. 11 markers placed, 11 spots where the bucket's nails detected hollow ground. The demolitions team investigated. They probed carefully around each marked location. 11 mines, every single one. German S-mines buried shallow with minimal metal in their casings. The electronic detectors had missed them completely because the metal signature was too weak against all the battlefield debris. But the mines created voids in the soil, hollow spaces that rang distinct when Tommy's nails tapped above them. 11 mines that would have killed the 1st Infantry Squad to cross that cleared hedgerow. Webb took the results straight to Colonel James Richardson, the regimental commander responsible for the 2nd Division's advance through the San Lo sector. Richardson was a West Point officer who'd built his career on tactical innovation. He was also watching his regiment bleed in minefields while the advance stalled.
When Webb showed him Tommy's bucket and the detection results, Richardson made a decision that could have ended his career if it went wrong. He ordered a full field test. 6 engineer squads, 3 equipped with standard detectors, 3 with bucket detectors based on Tommy's design. A 500-meter hedgerow sector known to be mined. Every squad's clearance time and accuracy tracked and measured precisely. It took Tommy and a hastily assembled team of 4 engineers 2 days to build 12 bucket detectors. They worked around the clock, assembling buckets, cutting wire, attaching nails, testing each device to make sure it met Tommy's specifications. The supply depot became a bucket factory, producing 6 completed detectors per day. The test operation began on June 22nd. When it concluded 36 hours later, the results were undeniable. Squads using bucket detectors cleared their sectors with 73% more accuracy than the control group using standard electronic detectors. 73%. Not 8% like the modified SCR-625, not 12% like the chemical detection methods would have provided. 73% more mines found, which translated directly into fewer casualties, faster advances, safer routes for infantry and armor. The numbers changed everything. Before Tommy's bucket detector in June 1944, engineer squads in the St. Lo sector averaged 45 minutes to clear a 10-meter section of hedgerow. They found approximately 60% of the mines present. The other 40% killed soldiers who thought they were walking on cleared ground. 40% of every buried mine stayed buried, waiting. After the bucket detector entered service, that same clearance operation took 25 minutes per section and achieved 95% detection rates. The effective clearance speed doubled. The survival rate of infantry advancing through cleared sectors improved by 68%. Tommy had promised to find the mines the detectors were missing, and the math proved he'd actually done it. Richardson didn't wait for permission from Division Command. He couldn't afford to wait. Every day of delay meant more men dead, more attacks stalled, more German forces entrenching. By July 1st, over 200 bucket detectors were in service across the 2nd Infantry Division. Engineers worked in shifts, building new detectors from salvaged materials as fast as their hands could move. The modification was simple enough that any soldier with basic tools could build one in the field. No special equipment needed, no complicated procedures. Just find a bucket, punch some holes, attach some nails, and listen to what the ground tells you. The production scaled up faster than anyone expected. By mid-July, over 1,000 bucket detectors were deployed across all Normandy operations. The 1st Infantry Division heard about what one of their engineers had invented and adopted the technique immediately. The British XXX Corps were slower to believe it, skeptical that something so simple could work so well. But by late July, even the proper British combat engineers were using bucket detectors alongside their electronic gear. The contrast was stark and embarrassing for the experts who'd been working on the problem. The modified SCR-625 that Cambridge engineers had spent months developing produced an 8% accuracy improvement at best. Each unit cost over $400 to produce and install, required a trained specialist to operate, and took 45 minutes to clear a 10-meter section of hedgerow. Tommy's bucket detector cost $2, could be built by anyone with basic materials, and cleared the same section in 25 minutes with higher accuracy. The chemical detection papers that MIT researchers had recommended would have improved detection by maybe 15%. But the logistics of distributing test strips to thousands of combat engineers was a nightmare that would have consumed more resources than it saved. Tommy's solution required materials that were already available everywhere the Army operated. To understand what this meant in practice, look at Operation Cobra from late July 1944. Before bucket detectors were widely deployed, the Allied advance towards Coutances required 6 major hedgerow corridors. Engineers using standard detection methods needed 14 days to clear routes deemed safe enough for armor and infantry. During the advance through those cleared routes, 47 soldiers were killed by undetected mines. The operation was considered a success despite the casualties. Compare that to the advance towards St. Lo in early August after bucket detectors became standard equipment. A similar operation requiring 8 hedgerow corridors cleared was completed in 9 days. During the advance, only 6 soldiers were killed by undetected mines. The difference? 41 lives saved, families that got their sons back, platoons that kept their strength, attack momentum maintained because men weren't constantly getting blown apart in supposedly safe zones. German intelligence noticed the change by August 1944. Wehrmacht engineering staff officers were puzzled by reports that Allied mine clearance operations had suddenly accelerated far beyond what previous analysis suggested was possible. Advances that should have taken weeks were happening in days. Routes that should have been impassable were opening overnight. A captured American soldier under interrogation mentioned bucket detectors, but couldn't explain how they worked beyond "you drag it and listen." German engineers tried to replicate the concept, but missed critical details. They built similar devices, but used the wrong nail spacing, the wrong wire length, the wrong dragging speed. Close wasn't good enough. By the time German forces developed their own acoustic detection methods, the Allied breakout from Normandy was complete, and the front was moving too fast for static minefields to matter. The impact showed up in major operations. During the Falaise Pocket battles in August 1944, Allied forces could pursue retreating German units through mine sectors that would have stopped advances cold 2 months earlier. That extra speed meant the difference between trapping German divisions and letting them escape to fight again. During the push towards Paris, improved mine clearance allowed Allied armor columns to use secondary roads that German commanders had assumed would be impassable due to mining. The unexpected routes enabled flanking maneuvers that shortened the campaign by weeks. The Army officially recognized what Tommy had accomplished in September 1944. They designated it the Reeves Acoustic Detection System in engineering field manuals. Training courses were established. Every new combat engineer received instruction in bucket detector construction and operation as standard equipment alongside electronic mine detectors. The technique became so routine that soldiers didn't even think about its origins. They just knew that bucket detectors were faster than electronics for hedgerow work, more reliable in mud, easier to repair, and they saved lives. In October 1944, Tommy Reeves received a field promotion to sergeant. A 22-year-old sharecropper's son with an 8th grade education became a non-commissioned officer because he'd saved hundreds of lives and possibly saved the entire Normandy breakout from stalling in the hedgerows. The full scale of what Tommy accomplished became clear only after the war when analysts could review all the data. Between June and December 1944, his bucket detector system reduced mine casualties in Western European operations by approximately 62%. That was equivalent to saving over 800 lives. 800 soldiers who came home because Tommy remembered how his grandfather found hollow ground on an Alabama farm during the Depression. General Omar Bradley later wrote in his memoirs that improved mine clearance was a decisive factor in the breakout from Normandy. He didn't specifically mention Tommy by name, but the techniques he praised were built on the foundation of those bucket detectors. Every division in Bradley's command used the system that a farm boy had invented in his spare time using scrap materials. The enemies of innovation had been so sure they were right. The Cambridge engineers knew that electromagnetic detection was the answer, so they focused on circuit modifications. The MIT experts knew that chemical detection was more sophisticated, so they developed expensive testing compounds. The officers knew that a private with no formal education couldn't possibly solve a problem that experts had failed to crack. They were all wrong. They were wrong because they'd forgotten to question their assumptions. They'd forgotten that sometimes the biggest problems have simple solutions. And simple solutions often come from people who aren't trained to think in complicated ways. Tommy didn't overthink it. He just remembered how his grandfather found hollow ground on an Alabama farm during the Depression, and he asked himself why the Army wasn't doing the same basic things that any sensible farmer would do. Listen to the earth, pay attention to how it sounds when you tap it, trust that different things sound different if you know how to listen. It wasn't rocket science, it was common sense. The kind of common sense that comes from growing up poor and learning that survival depends on understanding the land, not controlling it with expensive equipment. By the end of the war, every Allied combat engineer in every theater had used Tommy's technique, whether they knew its origins or not. The bucket detectors they carried, the acoustic methods they employed, the lives they saved, all of it traced back to a rainy night outside Saint-Lô when a frustrated private couldn't stop thinking about his grandfather tapping the ground with a wooden pole. The war ended, but Tommy's bucket detectors kept working. The technique he'd invented in a Norman hedgerow in 1944 became standard procedure in combat engineering. When NATO formed in 1949 and needed to standardize mine clearance procedures across member nations, they included acoustic detection alongside electronic methods in the official doctrine. Post-war, commercial demining operations adopted similar acoustic principles. The simplified devices used in Cambodia, Vietnam, and Afghanistan for clearing old minefields trace their lineage directly to Tommy's insight that buried objects sound different than solid ground. Nobody paid Tommy royalties. He'd never thought to file for a patent. The idea belonged to the Army, which meant it belonged to everyone, which meant it belonged to no one. Tommy Reeves went home when the war ended in 1945. He was 23 years old, a decorated NCO who changed combat engineering forever, and he just wanted to go back to Alabama. He'd seen enough of Europe. He'd done his part. Now he wanted to be home, where things made sense, where people talked straight and worked hard and didn't make things more complicated than they needed to be. Back in Tuscaloosa County, Tommy bought 40 acres with his service pay and started farming. The land was nothing fancy, just red Alabama clay with decent drainage and enough rainfall to grow cotton and corn. He built a small house, married a girl from the next county, started a family. Tommy never talked about the war.
When neighbors asked if he'd served, he'd say yes and change the subject. When they pressed for details, he'd say he'd been a combat engineer and leave it at that. He didn't mention the bucket detectors or the mines or the fact that he'd saved hundreds of lives with an idea so simple that trained engineers had dismissed it as stupid. That wasn't false modesty. Tommy genuinely thought what he'd done wasn't special. He'd noticed a problem and fixed it the same way he'd fix a broken plow or a leaky roof. That was what you did when something wasn't working. You figured out a better way. Why would anyone make a fuss about it? He never sought patents or tried to profit from his invention. The idea that he should own the acoustic detection concept never occurred to him, and if it had, he'd have dismissed it as silly. The modification had been done on Army time using Army materials to solve an Army problem. It belonged to the Army. Simple as that. Besides, Tommy never wanted to be famous. He wanted to make enough to live on, maybe pass some land to his children, and spend his days working with his hands on things that grew. The farm gave him that. He was content.
Tommy married in 1946, a quiet school teacher named Sarah who'd grown up on a farm near his family's old plot. They had 3 children together. Tommy taught his kids to read the land the same way his grandfather had taught him, with patience and attention to detail and respect for what the earth could teach you if you listened. He never pushed them to follow him into farming. He just showed them what he knew and let them choose their own paths. None of them became farmers. One became a teacher, one an engineer, one a doctor. Tommy was proud of all 3. The years passed slowly in Tuscaloosa County. The farm prospered in a modest way. Tommy never expanded, never tried to grow into something bigger. He liked working the land, like the quiet satisfaction of planting seeds and watching them grow. He farmed into his 60s, only selling the land when arthritis made the work too painful to continue. He died in 1992 at age 70. The obituary in the Tuscaloosa News mentioned his World War II service in one sentence. It didn't mention the bucket detectors. The engineering community remembered, though. They remembered slowly and incompletely. A few military historians who specialized in combat engineering wrote about the Reeves acoustic detection system in technical journals that almost nobody read. An Army field manual from 1978 included a brief footnote crediting Sergeant Tommy Reeves with developing an improved mine detection method in 1944. That was all. In 2004, the Army Corps of Engineers finally got around to honoring him properly. They awarded him a posthumous Legion of Merit, which his children accepted at a small ceremony at Fort Leonard Wood. The citation praised his ingenuity and his contribution to Allied victory in World War II. His daughter cried during the ceremony. His son stood stiff and uncomfortable in suits they didn't wear often. They were proud of their father, but also confused about why it had taken 60 years for anyone to officially recognize what he'd done. Tommy would have been confused too. He'd have said thanks, felt embarrassed by the attention, and gone back to his farm to check on the cotton. But Tommy's legacy kept growing in ways he never could have imagined. UN peacekeeping forces in the 1990s studied the Reeves detection principles when they were developing demining protocols for Bosnia and Cambodia. Modern ground-penetrating radar systems use acoustic feedback as a secondary verification method, a direct descendant of Tommy's insight that buried objects sound different than solid ground. And that difference can save lives. The commercial demining organizations today train operators in acoustic detection techniques alongside electronic methods. The handheld devices used in Afghanistan and Iraq incorporate acoustic sensors that work on the same principle Tommy discovered: hollow ground sounds different than solid ground, and that difference can save lives. The sophisticated mine clearance robots used by modern militaries include acoustic detection arrays as backup systems. The sensors are computerized now, with digital signal processing and AI-assisted pattern recognition, but at their core, they're doing what Tommy's bucket did 80 years ago. They're listening to the earth and paying attention when it sounds wrong. Sometimes the biggest breakthroughs cost almost nothing. They don't require years of research or millions of dollars in funding or teams of experts with advanced degrees. Sometimes they just require one person who's willing to look at an old problem from a new angle. Someone who isn't so educated that they've forgotten how to see the obvious. The Cambridge engineers were brilliant men who knew everything about electromagnetic theory, but they'd never tapped the ground with a pole to find sinkholes. They'd never learned that the earth tells the truth if you ask it the right questions. Tommy had learned those lessons before he turned 15, and those lessons let him see what the experts couldn't. A 22-year-old sharecropper's son with an 8th grade education saw what seasoned engineers missed. He looked at a mine detector and asked a question nobody else had thought to ask. What if we're listening for the wrong thing? That simple question reduced mine casualties by 62%, helped break the Normandy stalemate, and reminded everyone who paid attention that expertise without curiosity is just educated blindness. The next time someone tells you, "That's how we've always done it," remember Tommy Reeves working alone with a bucket and some nails after midnight. Remember him listening to the Norman soil and refusing to accept that men had to die because expensive detectors couldn't tell a mine from a nail. Remember him proving that common sense and careful observation can beat credentials and authority every single time. Tommy Reeves never accepted the answer that things couldn't be different, couldn't be better, couldn't be fixed with simple tools and clear thinking. He changed the course of World War II with a bucket, some wire, and a bit of common sense wrapped in the stubborn conviction that problems exist to be solved, not to be accepted.